Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is find the kth smallest pair distance. Okay, so you will be the distance of a pair of integers a and b is defined as the absolute difference between a and b. Okay, and given you will be given a integer array nums, and you will also be given an integer k. Okay, and you have to return the kth smallest distance among all the pairs in this particular nums array. Okay, where the between all the pairs I and j, basically if we are taking the absolute difference, whether you take the jth index first while subtracting them, or ith, it does not really matter. So you uh, the only condition is that the index should not be same. Okay, so these two indices should be different. Okay, and so you have to consider all the pairs, and among all the pairs you have to return the kth smallest distance among all the pairs possible in the given nums array. Okay, so for example, if 131 is the input array and the k is given to be 1, then these will be the following pairs there, and their differences are these. Okay, okay, so then you have to return the first smallest pair, which is the pair 1 comma 1. Okay, which is having a distance of 0. Okay, so let's take another example. In this you can see that all the pairs will be 1 comma 1, and you have to return the second one. So from all these pairs, all of these will be having 0 distance, so you will be returning the 0 kth smallest distance, which is 0. Okay, so similar way you will keep approaching, and let's see what kind of approach we can use to solve this particular problem. And before thinking of an approach, it is advisable to have a look at the constraints, so that we can decide what kind of approach will be suitable to solve this problem, provided the given input constraints. Okay, so the length of the nums array will be of order 10 raised to power 4. Okay, and each entry in this nums array that will be given to you will be of order 10 raised to power 6. Okay, and k will be well within the range of number of possible pairs. Okay, from 1 to n into n minus 1 by 2. Okay, and so these are the constraints. So if you try to do a brute force way of solving things, then you know you will try to form all the pairs. Okay, for that you have to run a nested loop. Okay, so if we are considering a brute force way, then you will try to form a numbers pair with every number possible, and it will result into order of n square time complexity just for forming the pairs. Okay, finding the kth smallest pair is a different thing. Just for the forming the pairs, you will be requiring n square time complexity. Okay, why I am saying n square, because you will be running two for loops. One will be the loop for the current number. Okay, and another for loop will be a nested loop, which will be for the number it can be paired with. Okay, pair of current number. Okay, so just for making pairs or forming pairs, you will be requiring order of n square, and as per the constraints, the order of length of this nums array was of 10 raised to power 4. So 10 raised to power 4 square will be 10 raised to power 8, and there is a limit of number of operations that your program can perform, and that limit is 10 raised to power 8 operations. Okay, So your number of operations should be less than that, but here it's not less than 10 raised to power 8 ops limit. Okay, so your solution might not be accepted and you will get a TLE. Okay, so in order to avoid this, you might be wanting to reduce your number of operations required by your program. Okay, so reduce number of ops required by solution. Okay, so we need to optimize our approach, need it to be optimized. Okay, so what we can do here is we can try to have a look at the constraints again and try to take some hints of what kind of approach would be more suitable rather than going just the brute force way of forming all the pairs. Okay, so as you can see, the entries in this nums array are from 0 to 10 raised to power 6. Okay, and the problem is asking us to find the distance between two integers. Okay, so if let's say we want to find the minimum value in the array, it can be 0. Okay, and the maximum value can be 10 raised to power 6. Okay, so from 0 to 10 raised to power 6, your difference, the kth smallest difference must be lying well within this range. Okay, so the kth smallest distance must be lying within this range. Okay, so your difference or the distance between two numbers will be from ranging from 0 to 10 raised to power 6. Okay, because entries are ranging from uh, 0 to 10 raised to power 6. Okay, so there can be a 0 entry and there can be a 10 raised to power 6 entry. So you will search for all the possible. So now the next step is, the next intuition that should be coming to your mind is, okay, so we can do a search for the answer. Okay, search for the answer within this range. Okay, so what is the range and what is the answer that we are looking for? We are looking for the kth smallest distance. Okay, kth smallest distance among all the pairs. So kth smallest distance is the answer that we are looking for. Okay, and we will search within this range. This range I am talking about, from 0 up till 10 raised to power 6. Okay, so what you will be doing here is, uh, a way to do it is using binary search. So what binary search does, it does that if you first of all, if you are not familiar with binary search, then although I will be explaining the binary search approach here itself, but I will also encourage you to go into the description box and find a link on the article related to binary search, and you can explore that article, and then you will be able to understand this in a much better way. Okay, so what binary search will do, first of all, it will select a mid value between these two extremes. Okay, so currently our extremes are these. Okay, let's take some other color, let's take this one. Okay, so currently our extremes are these. So let's say you find binary search will say that, okay, this is the mid value, midpoint. Okay, or you can say that binary search will say, instead of midpoint, a more uh, good variable name would be proposed difference. Okay, binary search will say to you, okay, I am proposing this difference to you, and try to find out whether this proposed difference can be your answer. For that, next part will be, we will try to validate if the proposed difference by binary search is uh, a suitable candidate to be the answer of our problem. Okay, is valid or not. Okay, so we will try to validate it. How we will be validate it? Okay, so for validating it, what we will be doing here is we will be counting the number of pairs having this difference. Okay, so in order to do this step, you will be counting the number of pairs having this difference. Number of pairs having proposed difference. Okay, so if let's say you are wanting to see how many pairs are having this proposed difference, then let's say there is a function that will return you this, and it is found to be equal to k. Okay, so let's say the pair count was found to be equal to k. Then what will binary search say is, okay, you validated my proposal, let me try to minimize the proposed difference a little bit further. Okay, so you can store keep this answer with you. The right now what is the proposed whatever I proposed you as the difference. Okay, and let me try to find out something shorter, because we are trying to find out the smallest thing. Okay, so we will try to go to the smallest possible thing, and we will try to search in this search space. Okay, if our proposed difference is validated. Okay, if is valid, then you will search in this search space. Okay, and try to reduce the proposed difference further, although you are all already having one proposed difference, but we will be greedy and we will be try to further minimize this proposed difference. Okay, we are trying to see are there some other differences lesser than this proposed difference that might be having same pair count. Okay, so we will try to do that in binary search, and I will show you in the implementation how we are implementing that. And this is the case in which proposed difference was found to be a valid proposed difference. But what if the proposed difference was not found to be a valid uh, proposed difference? Okay, so in that case your pair count will be, so if even if the pair count is larger than the proposed k, let's say this kind of situation also occurred. Okay, so we can take that case into consideration in this part only. Okay, so let's remove this and let me write it again here. Okay, so in that case also you will search in this part only. Why I am saying so? Because if this kind of input is given to you and you are asked to return this, then you can see that there will be this kind of you know pairs that you can make. Okay, so all of these you can see are having 0, and since 0 difference was having 3 entries. Okay, so you can see that it is having more pair count, but still it will be our answer. Okay, that's why we will still store we will keep the greater than condition also in our present condition. Okay, of checking a smaller proposed difference. Okay, and what if it's the other way around? Okay, let's say this condition is not holding true, and our pair count is lesser than k. Okay, so in that case you will say that okay, this is not valid, we must be searching for a larger proposed difference. and try to search in this half. Okay, so your binary search will be searching in this half, and each time your the halves or your search space will be divided into halves. Okay, so binary search divides your search space into halves each time. Okay, your search space into halves. And why one of the reasons that came into my mind that binary search can be applied here was because first of all I noticed that the answer must be lying within this range 0 to 10 raised to power 6. And if you know the time complexity of binary search, it is here the let's say the range length is n. Okay, so it, let's say it's of n length, so it's order of log of n. Okay, so here this n, and this log is of base 2, so it's very close to log base 10. Okay, so a close of in order to convert it, the values will not be that much different. And you know that 10 raised to power 6 log of, or let me take a new slide here, log of 10 and 10 raised to power 6 will be 6. Okay, and a close approximation that we can use to convert it into log base 2 is 3.32 times of log base 10. Okay, you can keep this formula in mind, but it is sufficient to know that the values will not be that much different. Okay, so they will be close to that. Okay, it will be 18 or 19 something in log base 2 for 10 raised to power 6. Okay, so in about 19 of searches you will be having your answer. The whole logic or the whole bottleneck will be to optimize this validation function. Okay, so this needed to be optimized. Binary search will take only about 19 operations in this case. Okay, so this needed to be optimized. So validating function needs optimization. That should not be increasing your time complexity to, let's say, order of n square. That will result into time limit exceeded again. Okay, for that what we will do is, so let's discuss how we can validate things. Okay, for that a very intuitive way that you can think of is, first of all you can sort your array out. Sort the array in, let's say I prefer increasing order. Okay, so if the array is sorted in a particular order, okay, then you will be wanting to count the number of pairs that will be having uh, you know difference less than or equal to the proposed difference. So number of pairs having difference less than or equal to the proposed difference by binary search. Okay, so for that what we will be doing here is, you will be using a sliding window kind of approach, because you can take two pointers, left, and let's take the second pointer. Okay, and right pointer will always be moving in this direction. Okay, ahead of the left pointer. And basically this is just a standard implementation of sliding window. If you are not familiar with sliding window, then again I will provide a link of an article explaining what sliding window is. Okay, so what you will be doing here is, uh, first of all, the difference between the right and left values should be not greater than the proposed value. Okay, and if it is happening, then what you will do, let's say for example, uh, just a second, let's say your right was somewhere at this position, let's say it was at 4. Okay, and your left was pointing to 1. Okay, now the difference between 4 and 1 is 3. Okay, but let's say the proposed difference was 2. Okay, so you need to somehow reduce your difference so that the pairs can be counted. Okay, for that what you will be doing is, you will be shifting your left to towards right. Okay, you will be shrinking your window size. Okay, earlier your window was this. Okay, now you will shrink your window size to this. Let's pick this color. So your new window size should will be this much. Okay, so 4 was always also there in this white window. Okay, so by moving your left pointer towards right, you just shrink your window size, and then you can easily count the number of pairs. Okay, so I hope you are able to understand. So 4 will be able to form pairs with both of these. Okay, so that's why your pair count will be increased by that amount. Okay, so I hope right now it's clear to you, and this whole thing will be taking order of n time complexity, where n is the size of the given nums array. Okay, so in all, how much will be the time complexities? The binary search was taking order of log of log base 2 of range size. Okay, and into order of n for sliding window. So this will be used by sliding window, or let me write down clearly here. Okay, for validation of proposed binary searches, proposed differences by binary search, and this will be used by binary search to search upon the range. Okay, for making proposals for this proposed difference. Okay, so what happens in binary search is, binary search have a function to validate or to decide which half to search for the next time. Okay, when it will be reducing your search space to half. So this validation function is that function. Okay, so because it will be nested inside binary search, that's why we are multiplying the complexities. So let's have a quick look at the implementation. Although it's quite similar to what we have already discussed, the only thing is to implement these two approaches as a single approach. Okay, so this is the implementation, and let's discuss what's happening inside this code. Okay, first of all, as I mentioned, we will be requiring to sort the array for applying sliding window, for validation of proposed difference. Okay, by binary search. This is where the validation part is happening. Okay, it will be returning you the number of pairs, and then you will validate whether the number of pairs are what we are requiring. Okay, so as we discussed, our ranges will be from 0. Okay, and whatever is the biggest number in the given array minus the smallest number. Okay, that range was that we were talking about was in terms of order of uh, size of integers that will be inside our array. But if we want to just take the actual size, actual difference, then the largest number minus the smallest number. Okay, so in this range you have to search for, and this is just a standard implementation of binary search. Okay, you will be proposing a difference, trying to find out the mid between two extremes. The two extremes are left and right. Okay, these two. And then if you are proposing this difference, then you will count the proposed difference pair count. You will be having the number of pairs having distances differences less than or equal to the proposed difference. Okay, so number of pairs having difference less than or equal to proposed difference. Okay, so this function will return you that, as we discussed, we will be using sliding window for keeping size of two extremes of the windows, track of two extremes. We will be using left and right pointers, and we will shrink our window till our proposed difference is smaller than the current difference between the two extremes. Okay, and we will keep doing so. Ultimately, if we are left and right are at the same point, then proposed difference will reach to 0. Okay, and that is the minimum value proposed difference can be having. Okay, so you will stop when right and left pointers coincide. Okay, and the number of pair counts I already told you, like here 4 can pair with these two. Okay, if the window size is this. Okay, so that's why using right minus left, and then you will be simply moving your right pointer or sliding your window one step further at a time. Okay, towards right, and then you will be returning your pair count. So once we are having the pair count, then we will check if we want to increase the proposed difference. Okay, so we want to search on the right hand side of the proposed difference. Okay, so in that case we are searching in this area. Okay, or let's change the color here. This area we are searching in, if proposed difference, if the number of pairs was less than k. Okay, and if it is greater than or equal to k, then we will say that okay, we are having one answer, possible answer, and we will try to reduce proposed difference more. Okay, and try to validate if we can find out lesser proposed difference or lesser answer. Okay, so then once this whole thing will be terminated, you will be having your answer, and you will be simply returning that. And I think we have already discussed the complexity time complexity part. For the space complexity part, you must have observed that we are not using any extra space here. We were just using sorting. Okay, so space complexity wise, it's constant. Okay, and time complexity wise, I already told you it is this. This is your time complexity. Okay, range size will be of order 10 is to power 6. That's why I am not considering this n log n time complexity due to search, because the length of the array is having a smaller size or smaller constraint limit. It's 10 raised to power 4, but the entries in the array are larger. That's why I was considering that. Okay, otherwise this would have been, time complexity would have been n log n. Okay, so anyways, this will be your complexity, and this will be okay, space and time. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Until next time, keep solving more and more problems, and I will see you in the next video. Thank you for watching.